So here we have lab number 10. We're going to start off with the 0.2512 molarity of the sodium hydroxide. This is slightly caustic, so we do want to be aware of that. We don't want to get it on our skin. If we do, we want to pour or rinse that off with soap and water very quickly. We are going to get this sodium hydroxide poured out of the stock container, put the lid right back on it, set that away. We cannot get these mixed up, so this is in a separate beaker. This is your burette or burette. Make sure that the stopcock is closed. We want to add 4 or 5 milliliters, just enough to get everything coated. We're spinning this. Again, if any of this drips down onto my hands, I am going to rinse that off quickly. I'm not going to wait. So this we can discard of that, making sure that it works. So we're going to do this a second time, making sure that the stopcock is closed. So that's a little more than 5 milliliters. So why do we do this? We do this to make sure that there's nothing but sodium hydroxide in this. Any residual water, anything, any hard watermarks or anything like that, some of the that stuff would be rinsed out. What we want to do now, this is a trick, especially for you short chemists. What we want to do, instead of raising this beaker of caustic material over our heads and pouring it, what we want to do, we can bring this to the edge, making sure this doesn't fall off. Bring this down if you want, or bring this down, making sure it doesn't touch below our face. That way it's not going to spill. Making sure the stopcock is off. We could use a funnel if we needed to. We can go up above the 0. We're going to drain some of this anyway. Careful not to let it spill or get off the edge. If it does, we will need to clean that up quickly. Don't let it get on your hands. Now bring this back up. Okay? One of the first things we're going to do, we need to turn this in the direction of the threads of the post. So we want to drain this down to a measurable amount. Right now it is not a measurable amount, it's above the scales. So what we're going to do, we're going to take empty beaker, and we are going to get all of the little air bubbles out of this. By doing so, this is going to let this come down, get all the air bubbles out. We're watching, we're watching, we're watching, and we can put this right on the 0 if we wish, and that is 0, because these graduations, this is from 0 to 1, that means these are tenths, those are tenths of a milliliter. Then that means that we can go out to the hundredths, and so that is 0.00 milliliters right there. So our next step is to obtain our unknown molarity of the hydrochloric acid. I would have at least 4, if not 7, different unknown molarities for the labs, one for each station. And so what we're going to do is pour some of this out. We're going to obtain this, and we're going to need at least 75. We're going to need closer to 100 milliliters, a little more, for each lab. So we're going to do this at least 4 times, maybe more. we're going to obtain, this is a 25 milliliter volumetric flask, so we're going to obtain 25 milliliters plus or minus, it doesn't say the plus or minus on this one, I believe it's plus or minus 0.03 milliliters. We're going to use our bulb. We place the bulb here, okay? Not too far up. We cannot get this glass above this, the T or the intersection. We're going to create a vacuum here. We're going to pull some of this up. We need to, this creates a vacuum at the top, pulls this up. We've got to get this clean. Now, I know it was clean last year, but we don't know how well they did. So we're going to clean this out. We're going to pull this up past the line. We don't let it get up into the bulb. It will ruin the bulb. And then we're going to discard this, okay? So now that we have cleaned this, we want to pull up our first sample and we're going to put it into a clean beaker. Notice how I'm trying to keep all of this secure. A lot of this lab is technique and getting you comfortable with the glassware. So I can keep this at an angle. That means the tip of this pipette is not sitting directly down onto the bottom of the beaker and actually stopping up the flow of the hydrochloric acid. So once I get up here to the top, I am going to stop it, get down eye level with it. Whoops, I ran out of vacuum. So I can start there again. Get down here eye level. And here's my 25 milliliters. I'm going to bring this over here and transfer this by hitting E. And this is touch suspension. I don't want to reverse this and blow it out. Yes, it takes time. But remember, we're out there to 0.03, not 0.3, 0.03 milliliters. So we're out into the hundredths in making sure that we have an aliquot or a sample size of 25.03, or as close to that. So we're going to say it's 25.00 milliliters of the unknown molarity of the hydrochloric acid. And we can do that with our second one while we have it out here. So our next step is this. We have two samples of 25 milliliters each. We are going to place our Teflon coated magnetic stirring bar so that it will sit in here. You need to make sure that this is going to be able to fit underneath of that. We need to add 2 drops of phenolphthalein using this pipette. If you use more than that, it will be way too much. 1, 2 drops. Put that back in. It is alcohol based. You will be able to smell that alcohol. So what's going to happen is the phenolphthalein will turn pink once the reaction has gone to completion and every bit of the hydrochloric acid has been reacted with the sodium hydroxide to make water. And so what's going to happen is that phenolphthalein in a basic pH above 7 is going to turn pink. And we want to be as close to that as possible. Now, to be able to make sure this stirring bar isn't splashing, we're going to add some distilled water. I am not adding any more hydrochloric acid. I have measured the moles, or the unknown moles, the volume of it already. So if I add just enough water, this is distilled water, not tap water, enough to get above that stirring bar, it's going to prevent that from splashing. At this point, we still have 0.00 milliliters of sodium hydroxide here. What we're going to do first, because this will save you time in the long run, we're just going to let this run until we see this color change. Why we're going to do that is because we know that if we do this, if we were to let this just drip and try to be perfect with this the first time, this could take us an hour. And so we're just trying to figure out ballpark, where is this at? So we're looking for some type of pinkish color, and we're starting to see that. Let me zoom you in. So we've gotten close because we see this pink color. So we're just going to let this, oh, and there it is. We went past. We want to be within 1 drop. But if we know that this started at 0.00, and I know that this is close to 28.3 whatever, I know that whenever I do this the second time, when I do this the next time, I know that I'm going to need about 26 or so. I can just drop in there. And then at that point, then I want to go really slow. Well, I know that I don't have that much left, so I'm going to have to add some more back to this. Okay, so at this point we know we need to get about 26 milliliters of this sodium hydroxide into this sample before it's going to be close. We're going to add a little, we washed this, we rinsed it, and we dried it before we put it in there, so there's no contamination. We're going to add just enough to make sure that gets above. The next thing is I filled this up, but I did not get it to 0.00. This is, I'm going to put my glove back here because it's a darker color, and I want to look at this and I'm going to say that this is 0.31. That is 0.31 milliliters. That is my starting point. That is your starting point. So we know that we need to go to about 26.3. We're going to go ahead and get this to stir. And we're going to drop it to about 26.3, and then we're going to slow it down. This one's a little touchy. Slow this down. What happens is we get a little bit of splashing up here around the side, and that means that part is not going to react. So we're going to drop this down to 26.3, which I'm just going to put my thumb right there, gently. I remember. I have my finger on the stopcock to quickly turn this off. All right, so at this point, I want to get down here closer because I know I'm within a milliliter or so, and I can add this just a few drops at a time. Keeping my fingers on the stopcock. I can turn this off very quickly or slow it down to even a slower drip. See how it takes a long time for it to clear up right there? That's what we're looking for. We're trying to get it to stay this very, very, very faint pink. I think it finally cleared up. We're probably within one drop. Very faint pink, and I believe it's going to stay. And it is very, very faint. The one thing you would have to do is if you add this water around the top, you'll notice I rinsed down a little bit more of that hydrochloric acid that has splattered out. That means that hydrochloric acid was not in the water to react. Now it is. It's going to stay the faint pink. It is not going to go away. So then I come up here and read this again. I don't think I changed my camera, but this to begin with was 0.31 milliliters. So my starting point was at 0.31, and now it is at 28.43. So 28.43. So if my ending is at 28.43 milliliters, I started at 0.31 milliliters. The amount that I used was 28.12 milliliters. We'll do this again 2 more times. So now that we have 2 more aliquots or samples of our unknown hydrochloric acid. We do have some left over in case we mess up. We've already added the phenolphthalein to both. This one's ready to go. We need to rinse this out. We're going to rinse this out 2 times with tap water. That's going to leave a little bit of residue in there. So then we're going to rinse it out 3 times with distilled water to make sure that it stays nice and clean as it dries until next year. So what I realized that I didn't do in the first trial was show you what I was doing. It was all focused down here. So here I'm going to look at this. I'm going to put my glove up behind it. It's 0.40. So I have 0.40 milliliters is my starting point. Again, I'm tall enough that I can see this. If you were a shorter chemist, you would need to bring this down so that it is eyeball level to see the meniscus. Or what I've also seen people do is take that phone, hold it up level, take a picture of it, and then be able to read it. And they also use that as their recording. So then I'm going to move this away from the edge. So 0.40 is my starting. Now my first trial was closer to 28 instead of 26. So I'm going to go to about, 27, 27 and a half. So I know it's going to be about right there. So at this point, I know where to start and stop. It's going to start there. It's going to stop here or close. And then I can get a much closer approximation. And it's going to save a huge amount of time that way. We're going to get that to where it just barely turns. It's got not enough liquid in it. It's going to spatter. That's why we're adding the distilled water so that that doesn't get up on the side. And so I'm going to go put my finger right here gently, and I'm going to just let it run. And as this runs, it's mixing. I've already got the phenolphthalein in this. Oops. I need to keep my eye on this. Focus. Focus. Because if I overshoot this, it's going to take me a long time to get this redone, to get everything started again. So at this point, I can get down here and I'm at about 27 or so. So I can maybe, I can add another half. And that is going to mix. I'm pretty sure it's going to be close to 28.12. I will go ahead and focus this in for you. So at this point, I'm not worried about reading this now. I'm more worried about making this perfectly, getting within one drop of turning this to pink. And I want to go one drop at a time the closer this gets. I don't know if you can tell, but that turned a super faint pink. It stayed for a little while. Stop that nonsense. Without this, we would be stirring this by hand with a glass stirring rod. So if you end up in a chemist lab that you don't have the stirring bar, you may have to stir this by hand. And this is not dissipating. I think it will. I'm turning it the wrong way. So there I got it. Within one drop. We can look at this. It is at 20. So I had to move that up. It is at 28 point. Wow, that's close. 28.59. 28.59. So if we have a 28. This is 9, 1, 28. Wow, we're pretty darn close, aren't we? Let's see what trial 3 does. I'm pretty sure we're right on top of this. So last trial. So whenever I put the sodium hydroxide into it this last time, I knew that I'm going to use about 28, it looks like 28 milliliters here. So I didn't want to fill this all the way up to 0. So I did some math here. If this ends at 50, I can't go past 50. I can't measure past this 50 down here. It becomes blank. So less than that, and then I thought, oh, I'll just fill it up to about 20 or so. Well, it kept draining down. So I am at 18.76 milliliters here. So I should be roughly down in here in the 46 or so by the time we end. And so that means I'm going to about 2 or 3 milliliters here, 4 or 5 milliliters by the time I get done. But that means I don't have very much waste. So I'm going to set my sodium hydroxide aside. I'm going to put in, again, I've got the phenolphthalein in here already, making sure that that's been taken care of. And then I can go ahead and get started. And so I know that it's going to be close to 46. I can just start adding. Notice the pink. The pink is starting to show up a little bit more. And I want to shut that off. And then I'm going to, very quickly, I'm going to give this a little bit of a rinse because some of it did splatter from whenever there wasn't a lot in there. Again, whenever I'm adding the distilled water, this is not doing anything to the reaction as long as that is pure distilled water. At this point, I'm going to add this very slowly until I get to that one drop. that one drop is staying pink, staying pink, staying pink. It's clear. I bet I'm within 1 or 2 drops. And I don't know if you can see this or not, but it is the faintest of faint pinks. You can tell that, well, it did turn clear, but because this has a white top, and we have obviously clear glass, it's easier to see. So within 1 drop, this is one, looks like it's going to stay a super faint pink. It's super faint. I don't know if you can tell on the camera or not, but this one is staying a faint pink. So we are really, really close to this equilibrium. It is still a super, super faint pink. And then we will read this. I am at 46.7, get even with it, 46.71. So at 46.71, let me see if I can take this over here. 46.71. So then that means 27.95 milliliters. So we are really, really close. We can do the average of this. And there we go. Should be good to go. We would clean this up. We will drain this sodium hydroxide. We can just go ahead and drain this in here. We'll add a little bit of acid until this turns slightly, or just within a few drops so that it turns clear, and then that can go down the drain because then it's just salt water. Then we want to rinse this 2 or 3 times with tap water, and then rinse 3 times really well with distilled water. That's the end of the lab.